All right, guys, we're looking at Math 7, Day 23. And today we're looking at Lesson 70. And we are covering volume. So a lot of these, actually all of these formulas for volume should be on your reference sheet. We can pull that up if we need to. I guess I can show you where we go again. References and school information from our homepage. Cheat sheet and measurements. And this one has conversions of different lengths, so our unit multipliers, and then just the general one will have our algebraic information, which we're not going to use all of this year by any means, but it has a lot of good stuff that I'd hang on to it all the way through high school. It'll help you out. And then on this sheet we have our different volume formulas, and then you may, well, what does the capital B mean? Okay, well, go up here, area of the base. Oh, okay, what does this little curved L mean? Okay, that's our slant height. Okay, what's R again? Oh, that's radius. So you have a key up here if you can't remember what these represent. What is pi? What is this symbol for pi? Well, it's up here. What is R, H, B, capital B, all of that. So this will help you. This will be very helpful, especially as you get working and taking tests and things like that. I don't expect you guys to have it memorized, and that's why I provide that with you. You have the information so you can just plug it in. But again, volume is the word used to describe the space occupied by a shape. So to measure volume, so it's three-dimensional, so length, width, and height. To measure volume, we use units that occupy space. So the way they explain it, again, I think it's good for kind of conceptualizing what's going on with volume, but I think it gets a little confusing when we get down the road. So I always just jump straight to the formula. If this helps you to think about what's going on, if we have this rectangular prism that was constructed of unit cubes, its volume is how many cubes. So again, I don't love this because this is just 1, 2, 3 by 1, 2, 3 by 1, 2, 3, 4. Yeah, we can do that, but if it was 20 by 30 by 50 or something like that, drawing this out or visualizing every cube is going to become way more work than it's worth. But for something simpler, understanding what's going on, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we would have 4 deep of those. So 9, 18, 27, 36. We would have 36 cubes in this. Again, I think it's easier. It's a rectangular prism, so we find the area of this square and multiply it by the height or the distance, or we can just do length times width times height. 3 times 3 is 9, times 4 is 36. I think that's much easier to just do the math than to, especially draw this out. It gets very, very kind of muddy and difficult to do, and then you're trying to visualize blocks that you can't see. So if we could actually pick this up, I think it'd be more beneficial, but it's not a bad way to kind of visualize what's going on with volume. So you will see some test questions that say, a 1 by 1 by 1 cube, there's 3 across, 5 up, and 6 deep or something like that. How many cubes are there? It's just asking, what is the volume? Again, if it's a 1 by 1 by 1 cube, okay, well, that is what we're looking at, a cubic centimeter or a cubic meter, or a cubic foot when we find volume. So again, I think they do it to kind of help you to make it easier and to kind of get you thinking in terms of volume. I think it can also be a little distracting and confusing at times. So again, I'll show you how I would solve this. Find the number of 1 centimeter cubes that can be placed inside a rectangular box of the dimensions shown. What I would do, I know what they're asking is me just to find the volume. So I would just do 3 times 5 times 4, because length times width times height for a rectangular prism, that's all we need. So 3 times 5 is 15 times 4 is 60. Now, if it helps you to see 1, 2, 3, 4, 5, and then 1, 2, 3, 4 up, and then 1, 2, 3, 4 deep. yeah, you're going through and trying to count all these and imagine ones in the middle there that you can't really see and counting them up. Again, may work for you. It kind of just makes it more confusing than me. To do 3 times 5 times 4, that's pretty simple. That's just multiplying 3 whole numbers. We've done that forever, and we come up with 60. Again, if you want to think of it in terms of these layers and how many are in each layer, then that's fine. But we're coming up with the same thing. So early on, they'll use kind of this imagery quite a bit. So if we have a 4 by 4 by 4 cube, cubes are even easier because it's really just length times width times height, but it's a cube, so they're all the same. So we're going to say 4 times 4 times 4, or 4 to the power of 3, and that's going to give us how many we have. So 4 squared is 16, 4 to the power of 3 is 64. Again, going through and visualizing and counting 64 cubes seems like a lot of work to me, when we can just say 4 to the power of 3, or 4 times 4 times 4 and be done. Yeah, that's what I would choose. Okay, some of these, just like two-dimensional polygons where we've worked with, you may have to break it apart into 2 shapes. Since this is kind of a rectangular prism on top of a rectangular prism, and it's not the same congruent shape top and bottom, it's not a prism, and we may need to break it apart into this. So we have a 4 by 4 by 4 cube. So the volume of that, 4 to the power of 3 is 64. Okay, and then down here we have an 8 by 4 by 4. So 4 times 4 times 8 is 128 cubic centimeters. And then we add those two. The same thing we've done with area of two-dimensional shapes. We can do the same thing with these solids for three-dimensional shapes. Break it up into 2 solids, or 3 or 4, however many you need to. Find the areas of them individually, and then add them together. All right, that's all we have for today. We'll start reviewing for the next test. We'll see you guys in class.